We're going to begin looking at trigonometry now. To begin with, we start with a circle, and we're going to call this a unit circle, a circle of radius 1. We impose an XY coordinate system with the origin at the center of the circle, and we first look at what we mean by a 1 radian angle. Okay? A 1 radian angle, and incidentally radians is the units in which we measure, radians are the units in which we measure angles in calculus. There's a very good reason for this. If we measure our angles in radians, then the derivative of the sine function, y equals sine t, would simply be y equals cosine t. Whereas if we were measuring in degrees, it would be something really awful. We'll see later that to keep things simple in calculus, we use the radian measure for angles. The radian is a natural measure. If we look at this as sort of an equilateral triangle, where we have radius r here and radius r here, and let's say that we'd started off with an equilateral triangle, so we had a straight line here, and then we beat the thing out into a circle, into a part of the circle, into an arc of the circle, the angle would decrease slightly, so that this 1 radian angle here turns out to be a little less than 60 degrees. The 1 radian angle is the angle that we get when the arc distance here, not the straight line distance, but the arc distance along the curve is equal to the radius. So it's sort of, again, an equilateral type situation. When we have a sector of a circle of radius r with an angle that we're going to call delta theta, we have associated that with that an arc distance delta s. Now let's ask what that arc distance might be and how it might be related to the angle and the radius. Going back to the original picture, a 1 radian angle has an arc distance of r. A half radian angle, common sense tells us that if we had half of the angle, we'd have half of the distance here, so we'd have 1/2 r. If we had a 2 radian angle, we'd have double the angle, so we'd have double the arc distance, we'd have 2r. That seems pretty obvious. If we make a table for delta theta and delta s, if delta theta is 1 radian, of course, delta s by the definition of a radian is equal to r. For half a radian, we're going to have half r, half the radius of the circle. 2 radians, 2r, twice the radius of the circle. Do we see a pattern here? Well, sure. Whatever delta theta is, if delta theta is half a radian, then we have half r. That's delta theta times r, isn't it? If delta theta was 2 radians, 2r would be just delta theta times r. So we can say in general that the delta s, the arc distance along an arc, is the radius of the circle times our delta theta. It's a very important relationship. Make sure you understand it. Make sure you understand it in all possible ways and understand it very well. Understanding this relationship is the key to proving that the sine of t has, the function y equals sine t has a derivative y prime equals cosine t. If you understand this, the proof of that theorem that gives us that derivative is very, very simple. In fact, simpler than calculating the derivative of the quadratic.